All right, welcome back everyone. So in our last video, we talked about threading and fasteners. So now we know what, quarter 20 UNC means, right? So what we're going to do is we're going to show how we apply this in Solidworks. And there are two methods to apply threading. There is physically modeling the threading, and then there is what we call cosmetic threading. And cosmetic threading essentially paints a veneer of threads onto your part. So it looks like threading, but there's no actual teeth modeled. And we'll talk about the pros and cons to each, but we're going to run through both of them today. So what we're going to start off with right now is doing cosmetic threading, and we're going to create a quarter 20 thread. We're going to do both a male and a female thread. So what we can do is we can start this on our top plane and create a sketch. And we're just going to draw two circles. Doesn't matter where they are. And around one of the circles, we are going to draw a box. Now we're going to set both of these to a 1/4 inch in diameter. We're going to model these as quarter 20 threads. So when we extrude this, this is going to be our male thread, and this is going to be our female thread. And those of you that were paying attention in our last video, you already know the issue we're going to run into here. But let's go ahead and extrude these, and we'll extrude them to 1 inch thick. That's perfect. So we have a 1/4 inch rod and we have a 1/4 inch hole. And what we're going to do is we're going to use the cosmetic threading feature to paint threads onto this piece. So the way we're going to do that is we're going to go to Insert, we're going to go to Annotations, and we're going to select Cosmetic Thread. Now what we do here, we're going to do these one at a time. We're going to do these separately. For thread settings, we're going to select just the edge here. And you can see it's already painted the thread on for me. Now, yours might not show up exactly like this. I'm going to show you guys how to fix that, but the actual appearance of the threads isn't important here. We're going to make sure that we're in ANSI inch, machine threads, and then here we can select our threading options. We're going to select quarter 20 so that we have 20 threads per inch. Now, when it comes to applying the threads, these apply just like an extrusion does, meaning we can do a blind, we can select a start face, and then we can choose how far we want this threading to go. Or we can do a through, which is essentially thread the whole thing, or up to next, which in this case is the same. So to do a blind threading, like I said, you select the start face. This is where the threading is going to start from, and you select the length. And this can be any length that you want. We'll thread this to 1/2 inch. If we want to flip the surface, we just select, let's see here. Select the other edge to start from. Where it actually starts from, it doesn't matter. This is just to illustrate the cosmetic threading for you guys. And we can go ahead and click OK. Now yours might not show up threaded. To actually see the threading, what we're going to do is we're going to come up here to Options. We are going to go to Document Properties, Detailing, and then make sure that this box here is selected, Shaded Cosmetic Threads. And you can click OK. And that should paint those threads on for you. Now, if you need to edit this cosmetic thread, it is underneath the Boss Extrude feature. So you'll see it right here. And then you can edit this like any other feature. And you can change this to 3/4, you can make it fully threaded, whatever you need to do. So let's go ahead and thread this hole now. Now we're going to run into an issue on this one, but let's go ahead and go to Insert, Annotation, Cosmetic Thread. And we're going to apply it just the same way as we did with the first thread. We're going to select this edge here. Okay, that looks good. We got threads in there. We're going to select ANSI inch, machine threads, and here's where we're going to run into an issue. Quarter 20 won't actually show up in here. You know, we've got 5/16, 3/8, 7/16, but no quarter 20. Now, as you remember from the last video, when we model male threads, we model it to the major diameter. When we model female threads, we model this hole to the minor diameter. So that's why we're not seeing quarter 20 pop up in here. This is a common issue a lot of people run into. So to fix that, what we're going to do is delete that second cosmetic thread. And we're going to edit this sketch. Now, like I said, we have to model this to the minor diameter. Now, the minor diameter for a quarter 20 thread is roughly 0.19 or 0.18. So we'll go 0.19. So if you were to actually make these threads in real on a milling machine, you would drill out this hole with a 0.19 drill bit and then run through a quarter 20 tap. But let's go ahead and exit this. Now, when we go ahead and apply cosmetic threads in here, annotation, cosmetic thread. Now you'll see quarter 20 pops up as an option for us. So just something to keep in mind when you're threading. Now, when it comes to threading SolidWorks models, this is the most common method to do it. And you'll see why when we actually go ahead and model physical threads. More often than not, this is faster, it's simpler, and it is less demanding on the system. When you model physical threads, there's a lot of geometry. So if you have an assembly that has 300 thread features, it's going to really bog down the computer. Cosmetic threads, since it's just painted on, it doesn't have that same issue. Now, another option you can use is the hole wizard tool, and we're going to talk about that. So what I'm going to do is I'm going to edit this sketch, and I'm going to delete this circle out of here. You guys can simply create a new square. It doesn't matter to me. And we'll delete this cosmetic thread. So what we're going to do is we're going to select the hole wizard tool and go to position. And I'm just going to put it right on the origin there. The actual position isn't important. But there is also a threading option in this hole type. And it's located right here. It's called straight tap. So we're going to select that. We're going to select ANSI inch. Now there are three types of tapped holes. A regular tapped hole, a straight pipe, and a bottom tap. Essentially what this refers to is the amount of taper. The two that we're going to use are tapped hole and bottom tapped hole. And to explain that, I'm going to go back to my fancy modeling software here. And when you drill a hole to be tapped, you're going to drill that hole out. And then when you run a tap through here, that tap is slightly tapered. And a tap is just essentially a screw that has flutes cut into it to cut chips. But that has a slight taper, and that's to aid the cutting process. So when it cuts threads, it's not going to cut it all the way to the bottom with a standard tap. And it's going to cut it, 3/4 to 80% of the way. And that's fine for most holes. A bottom tapped hole takes a tap that has no taper to it. So it's got threads on it, it's got the flutes, but it's perfectly cylindrical all the way down. And what that enables is for it to cut down to the very bottom of the hole. Now, there are issues with that we're not going to get into today, but just so that you guys are aware of the difference. So we're just going to choose regular tap tool. We're going to select quarter 20, and we're going to make this a through all. And we can go ahead and select OK. And you can see that'll do that for you in one step. So it's a little bit easier to use the whole wizard tool if that is a method you guys want to take. Now, like I talked about before, we were talking about screw heads. Now, we can also do those screw-headed holes in here as well. This first option is for a counter bore. This is for a socket head cap screw. Now, like I was saying, there are different diameters and different depths for the screw heads. With the hole wizard tool, we don't have to figure out what those are. It will calculate the right screw head size for us. So in this case, I'm just putting in, let's put in a number 8. Fit, typically normal is fine, and then through all. And that will cut that feature in there, that counter bore feature for a number 8 screw. And if I edit that to be a countersink for a flat-headed screw, you'll see it gives us two options: flat-headed screw 82 degrees, flat-headed screw 100 degrees. That's what I was talking about earlier. 82 is standard. And you can even see here how the 82 is just a little bit longer than the 100. And that's why we use the 100 for shallower materials. And that's going to go ahead and put that taper in for us. Right like that. So that's how to do cosmetic threading. Now let's go ahead and run through how to create physical threads. And since we're doing this, what we're going to do is go ahead and create physical threads for this vice screw here. And we'll actually run through modeling the threaded portion of this vice screw. So if we look at this thread callout, it's a 0.625-8 Acme thread. So we know our major diameter is 0.625, and there's 8 threads per inch, and it's going to be an Acme-shaped tooth. So like I said, what we're going to do is we're going to start with modeling the threaded portion here. Now to do this, we're going to do it in a roundabout way. It's going to take a few steps, but it will all come together at the end. We're going to start by selecting our right plane and creating a sketch. What we're going to do first is we're going to generate a helix. We're going to generate the spiral of the thread. For this, we're just going to grab our circle tool right around the origin and draw out a circle. We're going to smart dimension this to the minor diameter. So this is going to be 0.5. From here, we're going to go to Features, Curves, Helix, and Spiral. And what this is going to do is it's going to generate this little pigtail. Let me flip that direction. So it's going to generate this little pigtail. What we're going to do is we're going to define by height and pitch. So the height is going to be the length of our thread. Now in our case here, our thread is 3.937. I'm going to model this a little bit longer, and you guys will see why. So I'm going to model this at 4 1/4. Right like that. And then our pitch. This is the distance between the teeth. Now, as we said in our last video, our pitch is our threads per inch under 1. So it's going to be 1/8. So our pitch is 1/8. And there we go. We've got all of our teeth. Now, this next step is important. Our start angle. This has to be some function of 90 degrees. 0 degrees, 90, 180, 270, 360. Doesn't matter which one of those it is, but it has to be one of them. You can't have something like 75 degrees. The reason being, this helix has to start on one of our three planes: front plane, top plane, or right-hand plane. And it's only going to do that at a function of 90 degrees because those planes are spaced 90 degrees apart. So I'm going to start this at 90 degrees. So it's starting right here, which should be, I believe, my front plane. So you can see where my helix is starting. Now, once we have that, so we've got our height at 4 1/4, our pitch of 1/8, and our start angle of 90 degrees. We can click OK. Let's see. There we go. And what this has done is it's just generated this coil. What we're going to do is we're going to create a tooth profile. And that tooth profile is going to wrap around this coil. Picture taking a cookie cutter and threading a shoestring through it. However you manipulate that shoestring, the cookie cutter is going to follow that path. And in this case, it's going to extrude a tooth. So you can see where my coil starts here. That should be on my front plane. Yours may be different. That's not a problem. You're just going to choose the one that it intersects with. So I'm going to create a separate sketch on this front plane. What I'm going to do is I'm going to grab a center line that goes from my origin up to the start of this helix. Right like that. And then from here, I'm just going to rough out a trapezoid, because that is what a Acme thread looks like. So it's going to look something kind of like this. Now, when it comes to the dimensions for this, all you have to do is search the Googles for an Acme thread profile dimension chart, and you'll come up with this here. So there are only a few dimensions we need to know on this: our height, the angle of the teeth, and the thickness at the top. So let's start with our height. That is 0.5 times P. P is our pitch. So that is going to be 0.5 times 0.125. So what we can do is grab Smart Dimension and dimension our overall height, and that is going to be 0.0625. So half of 0.125. The next thing we're going to do is set the angle here, the angle of these teeth, and that is 29 degrees. So with Smart Dimension, we're going to click this side and this side, and that knows enough that we want to create an angle. So we're going to set that to 29. Next, what we're going to do is we're going to tell this line here to be equal to this line here. And that's going to help center this up. The way we're going to do that is press and hold Control, click on this line, and then click on this one. And we're going to set these to equal. Right like that. Now the last thing we have to do is to set the width at the top. And that is 0.3707 times our pitch is 0.125. Now, I'm not smart enough to do that in my head, which is good because SolidWorks will actually take care of this for me. In our Smart Dimension, we can actually type in equations. So we can type in 0.3707 times 0.125. And SolidWorks will put in the right value for us, and that comes out to 0.046 and some change. And with that, our sketch should be done. So what we have here is we've got our cookie cutter, and it's sitting on this shoestring. And what we're going to do is we're going to tell SolidWorks to wrap this around. So what we have to do is exit out of this sketch, and we're going to select the tool up here called Swept Boss Base. This blue box here, this is for our profile. This is going to be our cookie cutter. We're going to select this tooth. The pink one here, this is for our path. That's going to be our shoestring. That's going to be this helix. And you'll see that generate this big spring looking piece. We can go ahead and select OK. And there we go. So what we have here is just the threads of our piece. What we have to do now is generate the core, the actual solid metal piece inside here. That's really easy. All we're going to do is select our right-hand plane, or whichever plane you started on when you generated this helix. We're going to create a circle right around the origin, and that circle is going to be our minor diameter, which is 0.5 in this case. And then what we're going to do is we're going to take this and extrude it all the way through the center to the end. So we're going to go to Features, Extrude Boss Base, 4.25. And I'm going to reverse that. So now we have this thread right here. Now, do you notice how we have these square ends right here? This isn't typically how threads are formed. You'll typically see a gradual taper rather than this hard corner. And this is why we made our overall length longer so that we can trim these off. So on this end, all we're going to do is create a sketch on this surface. This is the starting surface. We're going to create a sketch, and we're just going to make a big circle here. We don't actually care about the diameter. We just want it bigger than our threads. And then we are going to extrude cut going this way. We want to chop off just this little pigtail. And we can do a through all cut for that. So we just wanted to chop off that little overrun of a pigtail. And we can click OK. And you see here how it's gone ahead and tapered this. Now we're going to work on this a little bit more in just a second. But that looks good. That's more typical of what we see from threads. Now on the other end here, we have essentially a length of our threaded rod, and this is 4.25. So on our end here, we're going to create a sketch, just like we did on the other end. We don't really care about the diameter so long as it's bigger than our threads. And we're going to cut this off the same way. However, the amount we're going to cut off is going to be 4.25 minus 3.937. So we want to cut off the difference between those two lengths. So 4.25 minus 3.937. Double check that, make sure that that's correct. Yep. And you can see it's cutting off, roughly 3 threads there. And there we go. So this length here, this is just the threaded portion of our threaded rod. Now, one last thing we can do to this is bevel these ends, because threads look close to this, but they also aren't quite as, sharp, right? This comes to like a really sharp corner. So what we want to do is bevel that. So on our front plane, we're going to create another sketch. We're going to run a center line going down the center of this. And then on each end here, we're going to draw a little triangle. Now the actual dimensions of this triangle aren't important. Something, kind of like that. Let's give this dimension of 0.1 and a length of 0.05. And then we're going to do that same thing on the other end down here. Yep. So I've got these two triangles here. What we're going to do is a revolved cut. So we're going to go to Features, Revolved Cut, and we're going to tell it to cut around this center line here. So you can see it taking those little triangles, spinning them 360 degrees to chop off the end, and click OK. And it didn't like that, did it? Let's edit that. I think that was just an artifact of SolidWorks, but let's go ahead and make this just a little bit taller here. See if that helps us out any. There we go. So what we've done is we've taken off that sharp, remaining corner on either end. And this is more typical of what we expect from a thread form. So from here, what you guys can do is you can go ahead and extrude out this bit here and this bit here. This should be pretty straightforward to you guys. It's just a couple of cylinder extrusions. I'm not going to run through it with you. But if you guys have any questions on this or on threading in general or any other aspect of this project, please let me know. And as always, have a nice day.